Hi, welcome to Cindy and Venus project. Here we'll introduce our chat application named ChatChat and how this chat system integrates GUI and secure messages. In the design stage, we want to ensure the clarity and security of ChatChat. We want to make our users comfortable with the concise but colorful GUI and also protect their account security and message privacy. So, to align with our motivations, we have such basic functions below. First of all, ChatChat has a login window with additional password entry. Users who open the chat system for the first time can input their names with passwords so that they can directly register their information, which could be stored in the server. Then, regarding the original interface, we add a list of new buttons and entries on the right-hand side of the chat box. Users could click on the button or type in what they want to achieve according to the menu and instructions. And finally, we apply the shared key methodology and Caesar cipher to encrypt the messages delivered among different terminals so that we can ensure the security, avoiding the information being leaked during server transmission. So now let's take a look at the demo for our project.
So let's first take a look at login. For example, username is 1, password is 123, and then if we click continue, it will say no such user, we need to create an account. And here we can just press register and it will show you that register successfully. Now you can log in. So what if like we use the same username but different password to log in and to register, and then it will show you that duplicate error, the user has already exist. And then now if we wanted to log in and then we are using like the wrong password here, it will show you that we are using the wrong password and we need to try again. So we can correct it into this correct one and log in. So after we log in, we can see that our group has changed the UI a little bit and changed the color. We add some buttons here. So here time, we can see the time, we just need to click it. And then who is now in the system. And then poem, we just need to enter the number and we can see the poem. So now we have opened two terminals and here we can simply by entering the username, we can connect them together. And here, maybe I can chat like, hi, I send it. And then we can see like the message hi from both users' chat room. And then, for example, I say bye, and then we will be disconnected. And now I can search for, and we can see the history of message here. And it's the same, we can all search them. So here we can see that there's a from user to a shared key is created, and this shared key is only between user 1 and user 2 so that their messages could be encrypted and the server won't be able to know what they are talking. So let's first take a look at the register part. So on the login page, we actually add the password label, the password entry, and the register button on the login page. And then here we can see that on the GUI, we would send the message to the server for status response, including the action register, name, and password. And then the server would create a dictionary. So the key will be the name and the value will be the password, and store all these in this dictionary and judge different scenarios. So here there are mainly two scenarios for register. One is duplicate and another will be okay. So when the status equals to okay, it will the GUI will get a response from the server, and then we can see this window suggesting that the user has registered successfully. Now they can just log in. And then the other scenario is duplicate, which means that in the dictionary in the server, there's already the username which already exists in the dictionary, so that we will pop up this window reminding that there's a duplicate error and the user has already exists, which means that our user needs to register a new one or use another one to log in. So the second part is about the login. So quite similar, the GUI sends the message to server for status response, including the action login, name, and password. And then the GUI will receive a response from the server to decide which if block to enter or which scenario it is. So there are totally 4 scenarios: no user, wrong password, OK, and duplicate. So for the OK, there won't be any new reminder window because it will go straight into the layout page. As for the no user, it means that when the message is sent to the server cannot find such username in the dictionary, and we will pop up no such user, create an account. And if like the dictionary in the user examines like there is such username, but the password is wrong, then we will pop up wrong passwords, please try again. And the third one is quite special because it only happens when someone registers successfully and log in successfully. However, he or she opens a second terminal and wants to log in with the same username and password, then it will pop up the duplicate error. Please enter a new name.
Now you can see that I have a new server running here. And then I open the login window to register a new account. After successfully registering, I quit the login window. But when I want to reopen the login screen and entered my username with password, I could simply press the continue button to log into the chat window. This means that if I do not shut down the server, I can directly log in again and start chatting.
So let's talk about the second part, secure message, including the encryption and decryption. So the methodology here that we use for encryption is actually creating shared keys through private keys and public keys. So to begin with, the terminals A and B would agree on a prime P and a generator G. So both of these values can be pre-shared and predefined. Then terminal A would generate a private key, A, and calculates the public key, and then sends the public key to B, and terminal B would do exactly the same thing. So after receiving the public key from terminal B, terminal A will use its own private key to calculate the shared key, S. And after receiving terminal A's public key, terminal B will use its own private key to calculate the shared key, S. So both terminal A and terminal B now have the same shared key, which could be used in encryption and decryption. So the method that we use for encryption is actually the Caesar encryption. So by shifting each letter backwards or forwards in the alphabet according to the shared key, we can encrypt and decrypt the messages. And here we can see that in our client state machine, in the definition of these initials, we added PG as predefined numbers, and here the private key A is actually a random integer, and the self key actually refers to the public key. For example, when user A is trying to connect to user B, there will be the action called connect, and we want to make sure that as soon as user A is connecting to user B, user A is going to send its public key to user B. Therefore, we actually added an attribute called key in the whole connect action. So the message that the state machine sends to the server will include its public key, and then the server will send the public key to every user in the chat room. So here, after A sends its public key to B, B needs to do exactly the same thing so that A and B could both calculate the shared key. So here we defined another action called return, which means that as soon as A sends its public key to B, B needs to send its public key to A. And here we can see that in this whole message, the receiver and the sender is actually switched. So this message will be sent from the client state machine to the server, and the server is going to function the return. So the public key B will be sent to terminal A. So now A and B both have each other's public key, and combining with their own private keys, they can calculate the shared key. So we here define the function shared key to calculate it. And in this way, they can encrypt and decrypt on their own client side. So here we can see that before we are going to send the message to the server, we're going to encrypt it. So we first find the Unicode of the letter, and then we add the number from the shared key, and then we mode it by 128, and then we find the corresponding letter so that every letter in this message is encrypted before it's sent to the server. And the decryption is simply functioning in the opposite way, which means that we first find the Unicode of the letter, and then we minus the number from the shared key, and then we plus 128, and then we mode 128 in case that the number is going to be negative. And then we find the corresponding letter according to the number that we get. So in this way, for the message appear in the GUI, the chat room it is gonna be decrypted. So through the private keys, public keys, and the shared keys, we successfully encrypted our messages, which means that it will be absolutely like just normal for these two users to chat in our chat room. However, if like any hacker hacks the server, he or she won't be able to know what messages are actually going on. What's even more interesting here is that we are only talking about user A and user B. So imagine there is a user C, and then when user C gets connected to the chat room, it will automatically send its own public key to both user A and user B, which means that if there are A, B, and C in the same chat room, then the shared key between AB, AC, and BC is going to be completely different, which is adding security to our whole message.
So after completing our project, we also have some reflections on how we can improve in the future. Our first enhancement should focus on the secondary verification. During the registration, we've already added the password entry, but there is no verification to ensure that the users set the password as their expectations. To address this, we need to let users re-enter their password to ensure they have the same passwords for twice. And second, to further guarantee the security of ChatChat, we could make the password invisible. There seems to be a security issue if the process of typing is visible, since the passwords may be hacked. This improvement also resonates with the first possible enhancement, because if the password is invisible, users would need the secondary verification more so that they could have the correct password. And finally, if we could add more kinds of multimodal elements such as visual aids rather than text, users will have much more fun using ChatChat. And that's all for our presentation. Thanks for watching.